Pete Hobbs is going to talk us through the scanner. Pete, what does it do? What do you use it for?
Well, the laser scanner it gives us the ability to create three-dimensional computer models of any terrain, for example, cliffs, landslides, and so on. It works on the principle of a pulse of laser light which goes out from the machine, bounces off the target, comes back, and the time of flight is measured. Now, this is happening hundreds of thousands of times a second. It's extremely accurate, and it enables us to produce models like this that you can see on the screen. And these models are not only accurate, but they are coloured from this camera, so they give the geologist a true impression of the geology, the stability, and any processes that are going on. And what we can do is that every 6 months or every year we can come back to the same location and repeat the survey, and we can look at the changes that have taken place.
And how quickly does it work? We're looking, I think, at the south coast, Dorset coast here, so a large area like that. How long would it take to survey that?
Well, this particular survey, which may be something like 500 metres in length, this particular cliff section, this might take about half an hour or so, or maybe an hour at the most with this setup. You have to move the machine along, so you can't do everything from one location, but various setups can be combined in the computer back in the office to give you one model, so it's a powerful tool.
And how accurate is it? What sort of increments are we talking about?
Well, the actual laser is very accurate. I mean, it's accurate to, I think, 2.5 centimetres over a range of over a kilometre, which itself is quite impressive. Of course, the accuracy of the model as a whole is also a function of how well you can position the equipment. So it's a vital component of the work is that we have a GPS attached, a very accurate GPS, which is able to position the equipment accurately and all the other locations that you survey from. That's a key point to the whole survey.
And I suppose you're always dealing in very small shifts, aren't you, when you're comparing one survey against to the next to therefore give you a bigger picture?
Exactly. We can be looking for changes in the cliff, something perhaps the size of a small suitcase. So if a piece of rock has fallen out since our last survey, we'd hope to detect that with this kind of equipment.
And I suppose the big difference is it's how quick it is, how accurate it is compared to what you've had to do before. It makes everything electronic as opposed to presumably before fairly manual.
Well, it opens up a huge range of possibilities for the geologist. It's a really remarkable piece of equipment, and it's a very exciting method for the geologist because he can analyse things such as cliffs, volcanoes, glaciers. He can analyse those remotely, so you can start to get very accurate surveys of features which would otherwise be inaccessible. You couldn't actually physically go up to some of these things and measure them with a tape measure because they might be too dangerous. So there are many uses that are coming to light for this kind of survey.